Now we have the questions. I hope we can all see the screen now. The first question is, a gas at a given temperature and pressure, a gas diffuses twice as fast as a gas B. It follows that. Now, when we talk about diffusion, this follows Graham's law of diffusion. Graham's law of diffusion states that the rate of diffusion of a gas is inversely proportional to the square root of its vapor density, provided that temperature and pressure and other physical condition remains constant. What does this mean? This implies that whenever we are at STP, in chemistry, STP means standard temperature and pressure. So whenever we are at STP, we have Graham's law of diffusion, in which a gas diffuses. Now, the rate of diffusion of a gas is basically on its density. Now, vapor density. Now, while we have vapor density, we have the molecular mass. Now, vapor density is different from molecular mass. Now, how do we get molecular mass from vapor density? To get molecular mass from the vapor density, we have to multiply it. That means 2 times vapor density is going to give us the relative molecular mass. As we know, that relative molecular mass is the concise mass that is present in that element or compound. Now, according to the rules, the laws I stated, which is the law of diffusion, I say the rate of diffusion is inversely proportional to the square root of vapor density. And as we know that 2 times vapor density will give us molecular mass, so we'll be looking at molecular mass, with the exception that if you're given vapor density, you have to multiply the vapor density times 2 to get the molecular mass. All right, so we have the rate of diffusion, which is now equals to square root of the vapor density. Now we're given two gases here. We have the gas A and gas B. I hope we are with our notes and paper. So we have the rate of diffusion of A to the rate of diffusion of B is equals to square root of the molecular mass of B to be equal to molecular mass of A. As we know that when we have inversely proportionality, we have when one increases, the other decreases. That means when the rate of diffusion increases, the molecular weight decreases. So at the long run, in the question, as you can see, it says that gas A diffuse as twice as fast as B. That means A is equals to 2B, right? That means A diffuse twice of B. I hope you're getting what I'm trying to explain. Since gas A diffuse twice as fast as gas B, so I have A is equals to 2B. Now, since A is equals to 2B, I know that I have to bring all these things into equation. That it will be RA over RB to be equals to, now, what are we going to do? We are going to square both sides. Now, to square both sides, you know that we are looking for the MB over MA, right? Now, we're given the rate of A and the rate of B. Now, that makes sense in the sense that the A is equals to twice of B, then I have B. So since A is equals to twice of B and I have B, so whenever I see RA is equals to 2B, right? Then RB is equals to B. So I have 2B over B, which is equals to square root of MB over MA. Now, according to mathematics, we have to take the square of both sides. Now, by taking the square of both sides, the square will cancel square root on the left-hand side, on the right-hand side. Then on the left-hand side, you have 2b squared divided by b squared, which will give us 4b squared divided by b squared. Now, at this point, we have b squared cancel b squared, which is equals to 4 over 1 is equals to mb over ma. Now, we're looking for the mb. Don't forget. So the mb will now be equals to 4ma. That means it will now be 4 times. The molecular weight will be 4 times. I hope you understand that. So the answer is B. Gas B is 4 times as heavy as gas A. So MB is equals to 4Ma. Number 2, we have isotope A has a half-life measure in minutes, where isotope B has a half-life measure in millions of years, which is more radioactive. Now, when we talk about radioactivity is the spontaneous emission or disintegration of radioactive elements. And why do we have radioactive elements? Because radioactive elements, they are substances that undergo decay because of stability. They are not stable. So because they are not stable, they have to decay. Now, by undergoing this decay, they breaks down until stability is reached. That is, radioactivity decay rate or activity is inversely proportional to its half-life. And what do we call half-life? The half-life is the time that you take a substance to lose half of its original value. All right, just like something melts to its half. So that's the half-life. So everything half-life, including your drugs, and that is why dosing frequency is permitted in drugs and administration because of half-life. And that's why I can say you should take a particular drug twice a day, and I can say a particular drug is once a day because of half-life. The shorter half-life means a much faster rate of nuclear decay per time compared to longer half-time. So the answer here is A, isotope A. Of course, we know what isotope is, which is the when we have the phenomenon or we have the element that have the same atomic number but different atomic masses. Now, number 3, we have the compound obtained when cellulose is completely hydrolyzed with a dilute mineral is what? Now, what do we call cellulose? Cellulose is what is outside the cell. Of course, it's the cell wall. We call it cellulose or cell wall. Cellulose is a linear polysaccharide, which is composed of beta and delta glucose monomer units. And when we hydrolyze this acid units, we're going to get breakage of all glycosidic bonds. So when we break all the glycosidic bonds, we are going to get glucose. So the answer is C. So number 3, we have C. Number 3, we have C. Then number 4, what alums are classified as what? Yeah. Now alum are classified as double salt. Now the formula for alum is potassium aluminate tetrasulfate 6-decahydrate. That's the name for alum. That's the formula. Potassium aluminate tetrahydrosulfate 6-decahydrate. So the answer is C. Which of the following, which is number 5, which of the following is not a covalent bond? Now let's look at what do we call covalent bond. Covalent bond is when there is sharing of an electrons. All right, there's a sharing of an electrons between two participating atoms. They are not necessarily metals and non-metals, but they are two participatory atoms in which both of them share. They share and give out their electrons. So it's just like one gain and the other one also gain. In biology, we call it mutualistic relationship. Mutualistic relationship is a relationship when both elements gain. So the answer there is magnesium chloride. Magnesium is the metals and chlorine is non-metal. So that's our answer, which is it is not covalent bond. The others are covalent bond. Now, number 6, iron rusts in air to form what? Now, when iron is exposed to air, there will be oxidation. All right, and that's what we call oxidation. Oxidation is the exposure of iron to air. So when we expose iron to air, we are going to get Fe2O3 and particulate water, because air contains a moisture, and that moisture, when we expose a substance, a particular moisture, is going to absorb the water, and absorption of the water, which leads to the rusting, which is B. So the answer is B. So number 7, electrolysis is not applied in what? Now we have application of electrolysis. Please, if you have your book, you can write it down. The acronyms is EPE. You can use EPE. EPE. So we have electroplating, we have purification of metals, we have extraction of metals. Electroplating, purification of metals, and extraction of metals. So these are application of electrolysis. Then electrolysis is not applied in what? So we have our answer to be C. We don't apply electrolysis in extraction of iron, as iron is not part of what we extract in electrolysis. Then number 8, which of the following is an allotropic form of oxygen? Of course, this one is kind of glaring. Now, when we talk about allotropes is when an element can exist in the same physical state, same physical form. All right, so the answer here is oxone, which is C. Oxygen can exist as oxone, it can exist as peroxide, and it can exist as superoxide also. So number 9, which of the following is the source of hydrocarbon? Of course, this one is kind of clear. Hematite is actually ore. It's ore of iron. Cassiterite is ore of tin. We have marble, which is wrong. So our answer is coal. So under coal, we have what we call destructive distillation of coal. Destructive distillation of coal is how coal is break down, and that's why we have coal tar, coal gas, ammoniacal liquor. So that one is hydrocarbon. Number 10, which of the following molecules is linear in shape? Now, when you talk about linear in shape, now if you look at the first molecule, we have methane, which is CH4. That's tetrahedra. If you look at the structure, it's tetrahedra. I'm sorry, I'm not able to share my screen now, but I'm still working on it. I will still be able to share it before the class ends. We have the tetrahedra. The B, the answer H2O. H2O is actually V shape. If you look at the shape, it's V shape. Then we have ammonia, that is triagonal. If you look at ammonia, can form triple bond, which is triagonal. Then we have the Cl2, and that is linear. The Cl2 form linear bonds, so that is the answer. So the answer is Cl2. Number 11, which of the following is not a compound of alkaline earth metals? So the answer here is potassium trihydrocarbonate 4. And what do you call alkaline earth metals? Alkaline earth metals are metals that have +2 charge. Please take note. We have alkali metals and alkaline earth metals. So the alkaline metals, they are the ones that have +2 charge. So if you look at potassium, if you break down potassium by electrolytic fission, we are going to have potassium +1 ion, magnesium +2 ion, the calcium +2 ion, and barium +2 ion. So the odd one out here is potassium, as it's having only +1 ion. The number 12, which of the following elements is diatomic? This one is kind of straightforward. Now, when we talk about diatomic molecules are molecules that can form a covalent bond with the same amount of molecule. That is, hydrogen can form a bond with hydrogen, and that's why we can have H2 gas. Chlorine can form a bond with chlorine, and that's why we have Cl2, and so on and so forth. Now, if you look at the first one, ion cannot stay as diatomic. It is monoatomic. Neon is a noble gas. All noble gas are monoatomic. None of the noble gas in this world is diatomic. They are monoatomic because of their own reactivity. They cannot react. Okay, so we have the oxygen. Oxygen can form diatomic, which is oxygen plus oxygen to form O2 gas. Sodium cannot form diatomic, so that is out of it. Number 13, which of the following can best be used to demonstrate fountain experiment? Now, when we talk about fountain experiment is the one that is carried out in the laboratory. And why do we carry out fountain experiments in the laboratory? It demonstrates extremely high solubility of certain gas, such as ammonia and HCl. This is the two gases that we use in fountain experiment are just basically ammonia and HCl. And because of what? Because of their solubility. I've explained that before, that before you can check if something is actually acidic or basic, you have to check if that particular thing that is acidic or basic, what is actually dissolving. And if you look at ammonia and HCl, they usually dissolve in water, which actually improves their solubility. We have number 14. Number 14 now. So number 14, the highest oxidation state of sodium is what? Now let's look at sodium. We know sodium is always +1. So how do we get +1? Based on the electronic configuration, we have 1s2, we have 2s2, we have 2p6, we have 3x1. So based on the sodium configuration, the electronic configuration says it has to be +1, which if we have the shell configuration, which is 281, that means it has 1 electrons in the outermost shells. This simplifies that it can lose 1 electron. And whenever a substance is losing an electron, it's becoming a positive. And because it's becoming a positive, it has to what? It has to combine with another element to stay balanced. Now, if 305 kilojoule of heat is evolved means it's released when 10 grams of methanol CH3OH is burned completely in air. The heat of methanol will be what? Now, the first thing we're going to do here, this actually is what we call part of electricity, but we don't call it electricity in chemistry, so we call it electrochemical cells. Now, in electrochemicals, in chemistry, we talk about the enthalpies and the entropies. Now, if you look at what they are asking you here, they're asking you the heat of methanol. So that is heat of combustion of methanol. So they are asking you heat of combustion. So heat of combustion is part of enthalpy. And what do we call enthalpy? Enthalpy is what? Enthalpy is the quantity of heat or the heat content of a substance, where we also have entropy, which is the randomization, degree of randomness or the disorderliness of a substance. So we have enthalpy, we have entropy. Now, in this kind of case, you are trying to calculate the heat of combustion, which you'll be using your formula, the enthalpy of combustion, which is the burning O2, is equals to enthalpy of products minus enthalpy of reactants. Now, before you get to enthalpy of products minus enthalpy of reactants, you must as well know that you have to calculate your products and reactants. And how do you do that? You have CH3OH, which is methanol. Now you have to calculate the molar mass of methanol. Now, to calculate the molar mass of methanol, you are already given from the bracket. We have the C is equals to 12, H is equals to 1, and O is equals to 16. So at the long run, you are calculating CH3OH. So that means 12 plus 1 times 3, which is 3, plus 16 plus 1. So if you calculate that, you calculate and you get your molar mass. Now, when you get your molar mass, you are told that 10 grams of methanol is what is needed. Now, since it's 10 grams of methanol, you have already calculated the molar mass of methanol, which is 32 grams per mole. Now, number of moles, according to number of moles, you have mass over molar mass. Now, how many mass was it burnt with that 10 grams? That's, we want to get the number of moles, which is 10 divided by 32 grams per mole. So we are going to be getting 0.3125 mole. Now, to get the heat of combustion, you have to use the formula Q is equals to the number of moles. That means the Q is the quantity of heat divided by the number of moles. So when you get the quantity of heat divided by the number of moles, you are going to get 305 kilojoules divided by 0.3125, which is giving you minus 976 kilojoule per mole, as you are looking at the combustion of heat. Then we have the octane number is highest in petrol containing high proportion of, I think we have answered this kind of question before. The answer is D, which is 2,2,4-trimethylpentane. So that's the answer. Number 17, which of the following is a characteristic property of a polymer? And what do we call polymer? Combination of different monomers, right, of the same unit. So when we have monomers, we combine them together. So that combining them together, we actually give them polymer of the same size. So whenever we have polymer, we know that they are what? They have high molecular mass because we combine different monomers or smaller molecular mass. So the answer is D. Now, number 18, we have the addition of the dilute hydrochloric acid to zinc sulfide evolves a gas called what? Now, when hydrochloric acid reacts with zinc sulfide, what gas will it evolve? Now, if you are going to write the reaction, if by writing the reaction out, you notice that when zinc sulfide is reacting with HCl, you are going to get zinc chloride, then plus hydrogen sulfide. So the answer is B, which is hydrogen sulfide. I think that one is quite straightforward. Hydrogen sulfide is what you'll be having, as hydrogen sulfide is the gas that will be released. Now, the functional group of amine is what? So the functional group of amine is NH2, which is derived from ammonia by the loss of one hydrogen. So when ammonia loses one hydrogen, it's turned to the NH2. So number 20, which form of radioactivity is most penetrating? So that is gamma emission. Gamma emission is dangerous and is the most penetrating. Is that the most penetrating power? Because it's dangerous. And that's why we always avoid gamma or exposure to radiation. Exposure to radiation is something that is very dangerous. So we don't allow exposure to radiation anyhow, especially gamma radiation, as it can cause damage to the skin and also to the internal organs. So avoidance of gamma radiation. Number 21, which of the following substances used to test for reducing agents? Now, what do you call reducing agents? Reducing agents are agents that undergo oxidation. I talked about it in the last class. Whenever we have oxidation, they're undergoing they are what we call reducing agents. That means ORA. Oxidation is going that they are reducing agents. So something is oxidation, it means is what? Reducing agent. Now we have A, B, C, D. So the answer is C, potassium heptaozodichromate 6 rather, potassium heptaozodichromate 6. That's the C, that's the answer. Number 22, the gas that smells like rotten egg is, the answer is hydrogen sulfide, H2S. So that's D, number 22 is D. So number 23 now, in the purification of town water, alum is added principally to what? We have coagulate. So we use alum to coagulate. I talk about example of alum, which is potassium aluminate tetrahydrosulfate dodecahydrate. And alum, this alum is used to coagulate. Of course, most of us must have used alum 1 or 2 times before. It's used to coagulate particles to actually get the particles to settle at a particular place. And when they settle at a particular place, we'll be able to sieve it. Number 24, catalyst increase the rate of chemical reaction by what? Now, catalysts increase the rate of chemical reaction by lowering the activation energy. And what do you call activation energy? Activation energy is the energy that is needed to start a reaction and to complete a reaction. So we use activation energy to increase the rate of a chemical reaction. So when we want to use the activation energy, of course, catalyst will reduce that energy that is needed for the reaction to be activated. So the answer is it's lowering the activation energy for the reaction. So the answer is C. Number 25, one of the adverse effects of chemical industry in the community is what? So we have increased environmental pollution. So the answer is D. It actually increased environmental pollution. And that's why we don't encourage having industry near to home, even having fueling station near to home is very dangerous and it should not be encouraged, as it can cause toxicity to the human that stay beside that. Now, number 26, petroleum fraction are generally separated by, we separate petroleum fraction by fractional distillation. So that's B, fractional distillation. Number 27, which of the following shows the hybridization of ethene? Now, when we talk about hybridization of ethene, we are talking about sp2. sp2, of course, helps in hybridization of ethene. Now, we have number 28. The following can be obtained directly from destroyed solution of coal, except we have the answer is producer gas. I've mentioned that earlier. I talk about ammoniacal liquor. I talk about coke. I talk about coal gas. Then the answer is producer gas. Number 29, the instrument used in determination of isotope is mass spectrometer. So that's mass spec. That's A. Number 30, non-polar. Non-polar molecules are held together by what? So when we have non-polar molecules, they are held by van der Waals forces. And van der Waals forces is internal forces that is very, very strong. It's very, very strong. So that's why we have van der Waals forces. So if you have a question on what I've been explaining, you can ask now.